Okay. We do not want to just find the slope, the derivative at one particular point. I want to get the whole graph of this derivative function. So I want to take this whole graph, f there, and I want to graph the complete entire set of derivatives at each point. And I don't have to do every point to figure out the derivative of each point. Here's what I'm going to do. What I note here is that, as you can see on the left side over here, well, let me back up. The best thing to do, I think, on these is first of all look for those derivatives of 0. And looking at this graph, do you see anywhere there is a derivative of 0? There is a derivative of 0 at 2. F prime of 2, in other words, is 0. Does everybody agree with that? How do we know that? Well, we know that because the slope of the tangent line right there. Slope, you got a horizontal tangent line. Slope of a horizontal line is 0. Therefore, the derivative is 0. So, at 2, yes, I do have a derivative of 0. Okay? So if I put that then over here on the graph of f prime on the right, where does that point go? Where should I put that point over here on the graph? If I'm graphing, the points of f prime, wouldn't that go f prime of 2 equals 0? So if I'm graphing f prime over here on the right, wouldn't that go right here? Yeah. On the graph of f prime, those horizontal tangents are going to be x-intercepts because that is 2, 0, isn't it? That's saying the derivative right here, probably can't see, not showing up on yours. Okay, so that point right there, 2, 0, that's saying at 2 the derivative is 0, because this is the graph on the right, is the graph of f prime. All right. Now, what happens on the right side of 2 then? You tell me. What kind of derivatives do I have over here? Sign-wise, S-I-G-N-wise. Draw a couple in. Aren't those positive slopes on the right of 2? Positive slopes on the right. So doesn't that mean, doesn't that mean f prime then? There we go. F prime on the right here, starting at 2 there. Let me mark off kind of middle there. On this side of 2, on the right side of 2 there, the derivative is positive. Okay? Well, you might also note here that if I kind of estimated that this one, the first one there to the right of 2, I'm going to estimate that to be f prime, say, equal 1. This one gets a little higher, rise maybe 3, run 1. So I'm going to say the derivative right there is 3. Right there. Derivative right there is 1. Then it gets even steeper right here. That's derivative, I don't know, 5, something like that. Right there. Okay. So here's the story. Out a little bit from 2, it's 1. A little bit further, it's 3. A little bit further, it's 5. So, yeah, those are going off kind of like this. They're going up, aren't they? This means your derivative, the line here means derivative's going up. As you go progressively from 2. Now what happens on the other side of 2? Well, let me draw a couple of those in. There's one, there's another one, There's another one. Those are what sign? Those are negative slopes. So that means the derivative, therefore, is negative on that side. And so notice those are progressively getting less and less negative. Because right here you might say, well, that's like a negative, I don't know, negative 5. This is a little less steep, so it'd be like a negative 3, and this is the counterpart there, maybe a negative 1. You see what I'm saying? Those are getting progressively less negative, which means over here, if you get progressively less negative as you go to 2, you're doing something like that. Yeah. So the graph of function f, the parabola is what it is, turns out to be this line when you graph its derivatives because of the slopes of the tangent lines, what they're doing. You with me on that? All right. All right, so we'll do a couple more in a moment. Let me slide on down here on the handout to B. All right, so on B, well, we have another deal, don't we? We've got the straight line. The graph is starting out as a straight line. What about the derivative? Well, we've already kind of talked about it. If I look at just one point here, it looks, let's start at 1. If I do a rise to run here, the slope looks like it's going to be a run to there, okay, right there. All right, that looks like it's going up about 2 units, so I'm getting a slope of 2 over 1 at that point, which means, what's the derivative? 2 over 1. All right, what's the derivative right here? Up here at 3. It's going to be the same slope, isn't it? That derivative is, I'm saying it's 2 over 1. So the derivative there is 2. The derivative right here is 2. The derivative down here, guess what? 2. Okay. Derivative is 2 everywhere you look. So when I come over here, it should be G's, I'm sorry. Change my function letter. So G prime is 2 everywhere we can see. All right, what does that mean for the graph? Well, the derivative at 1 is 2. So let's say it's right there. The derivative at 3 is 2. The derivative at negative 1 is 2. The derivative at negative 4 is 2. What's that turning into? A horizontal line. Yep. If part of your graph, all of your graph in this case, but if part of it's a line, then the derivative of that turns into a horizontal line. If the function's a line, the derivative turns into a horizontal line. That's what the derivative function looks like. Okay? Because the derivative is constant. So that means it's a horizontal line. Okay? Questions on that? All right, so C, here's our absolute value again. It's a little shifted over, but what do you see there? I see 2 lines. 2 lines coming together. One of the lines, all right, first of all, though, let's talk about that corner. What is happening on the corner there? Why are you doing that? Okay. All right. Yeah. The derivative does not exist here at the corner. We just talked about that. So f prime does not exist. Where is that? At 2? Because it's a corner. Any corner, derivative does not exist. Now, to the left of x equals 2 over here, what have we got? What are the slopes over here? You got negative slopes, and so the derivative is negative over here. On the other side of 2, you got positive slopes, so the derivative is positive over here. Now, the other aspect of this is those are straight lines. And what do straight lines, we just talked about, what do straight lines turn into when we graph their derivatives? Horizontal lines. Now, this one, let's say, let's just try to get a number here. I'm going to do it negative 1. So if I go from this point to this point, it looks like we've got a down 1 over 1, doesn't it? So it looks like the derivative is negative 1 over here. This is P. Pay attention to my letters. P prime, P prime. Okay? So it looks like, are you with me there? P prime is about -1. So isn't it going to be -1 all the way up until we get to 2? So over here, wouldn't that look like this? Down here, below the x-axis on P prime. You with me on that? -1. That's about -1. Until we get where? Until we get to 2. At 2, it doesn't exist, so I'm going to put a little circle there. Okay? Now what happens after 2, to the right of 2? Well, they turn into positive, and I'm going to say it's about the same rise over run, but it's a +1. So P prime on this side is +1. So where's the graph located there of P prime then? Well, it's up here. So I've got straight lines there, just one that's a negative slope, the other's a positive slope. So one's horizontal line below the x-axis, the other's a horizontal line above the x-axis. Okay? With me on that? Okay. Flip it over then, back page. For the graphs of the following functions, 1 through 3, choose the graph below, a through f, that is the graph of its derivative. All right, so this is doing the same thing, just you have some choices of graphs. But we're going to do the same thing. Let's start with number 1. Number 1, looking like how many, first of all, what are we going to look at? The zeros. If I'm going to graph this function, the derivative of number 1 here, let's look at the zeros. Okay, well, I've got it looks like a horizontal tangent right there, and I got a horizontal tangent right there at 2. All right, so I've got horizontal tangents at -2 and +2. What does that translate into on the graph of such a function, of the derivative of the function? X-intercepts, right? So those are going to be x-intercepts. So just taking a peek down here at my choices, do I have any that have x-intercepts at both -2 and +2? That should be a -1, isn't it? So that's between okay, yeah, it's between -1 and -2. Okay, so that, well, maybe it is it's -1. Okay. All right. B and F. Yeah, I'm with you there. B and F, both of them have x-intercepts there, -1 and +2. So those might be potential choices here. Let's fill in the rest. Okay. So what happens on the right, left, and the middle here? Well, if you draw in some tangent lines there, that's a little off, but you know what I'm trying to get at. You got a positive tangent, positive tangent. So the derivatives over here are positive, aren't they? Up until it goes to a slope of 0. On the other side, well, it turns into negatives, doesn't it? Negative slope, negative slope. So the derivative in here is negative. And then to the right then of 2, you got the derivative is positive. Back to positives. Gradually coming out from 0 there. All right, so do you see which one of those best fits then? Well, the derivative, when you go to the graphs, B and F, so I need, what was it, a positive, negative, positive derivative. On B, what is this one right here? What does this mean on B, right here, this part? That would be positive derivatives, isn't it? Because why is it positive derivatives? Well, I'm thinking on the x-axis. Yeah, it's positive derivatives on this side because those are above the x-axis. So you got, if you want numbers, you know, this is like +1 slope right here, 3 slope, 5 slope, just estimating, but so that translates over here to +1, 3, 5, you see. That's looking pretty good. What about the other side? The F. F doesn't look too good because these are negative numbers for the derivative. Remember this is graphing F prime, or whatever the derivative is. This is negative numbers for the derivative. -5, -3, -2. Okay. So it doesn't look like f is b. Now, why does b do this from -1 to 2? Well, it's because, notice, the action here. In the middle, that's the middle between -1 and 2. Between -1 and +2, isn't that what the graph, the derivatives are doing? You start here, small negative, then it gets a little bigger negative, -1, then it gets a little bigger negative, but then it starts progressively coming back to 0. That's what this does. You got -1, a little bigger, then it starts coming back to 0 when we get to that. That's looking pretty good. And then the positive slopes, yeah, it's positive slopes. Positive derivatives on that. Okay? All right, so that's B. 1 goes with B. What about 2? Well, 2 is a little bit easier, isn't it? 2 is your line. So the graph of it is a what? Horizontal line. And is it a negative horizontal line or a positive horizontal line? Well, it looks like you got negative slopes here. So the derivative means the derivative is negative. So I've got a negative horizontal line for its derivative. So which one is it? Out of all those, a constant negative slope. That's A, isn't it? Because you got a horizontal line that's negative down here. So yeah, that one's going to be A. Which brings us to number 3. Which ones of those would fit nicely? Again, graphing the derivative of number 3. Well, what have we got here? And here? And here? We've got corners, which aren't zeros. Does not exist. Yeah. So at those corners, so the f prime does not exist at -4, 0, and 4. Okay? So those are going to be, on your graph of your derivative, you won't have any point there at -4, 0, and 4. Okay? What else, though, do we have? Well, on this side of -4, to the left of -4 there, I've got a line. It's positive slope. So I've got a horizontal line that's positive on the positive side. Then after -4, between -4 and 0, I've got a negative slope line. So I've got a horizontal negative line. You know what I mean? Then I've got a positive, and then I've got another negative. Which ones of the choices? So I've got a bunch of horizontal lines. I've got a positive horizontal line, then I've got a negative horizontal line on the negative side. Which ones of those does it have? Well, we've got D and E, it looks like, are the ones of choice, but you say D? D's better than E? I think so, yeah. Because this one, on D, you've got a positive horizontal line on the positive side of things. Whereas on E, to the left of -4, you got a negative horizontal line. We needed a positive first, didn't we? It's D. And you see at -4, what have I got? Thank you. Then at -4, you see what I've got at -4? Got an open circle here, open circle here. Is that right? That'd be right, wouldn't it? Because the derivative does not exist at those, so I don't need a point there. And so I've got 2 open circles, which represents, and the same thing happens at 0. All right, so yeah, I'm good with D. All right? Okay. All right, so you might have to draw a couple, so you kind of know what the graph. If you kind of got a curve like this on number 1, you got a nice up and down curve like that. It's going to look. I mean, it may not be exactly like it, but it's going to look like B here